All right, let's dive right in. We all know the AI revolution is here, but what if I told you that everything we've seen so far is just the warm-up act? That is the core idea behind a really fascinating analysis from Morgan Stanley on Nvidia. And today, we're going to unpack their thesis and figure out why they believe one of the biggest technology buildouts in history is really just getting started. So, to get a sense of scale, let's just start with this number, $5 trillion. That's Morgan Stanley's high-end projection for the AI infrastructure market by 2030. And listen, that's not the total AI market with all the software and services. No, that's just the spending on the nuts and bolts, the foundational hardware that makes it all possible. It's an absolutely mind-boggling figure, but what does a build-out of that size actually look like?
Well, Morgan Stanley puts it like this. They say it's on par with the original construction of the internet backbone. I mean, just think about that for a second. Remember the sheer effort of laying all those fiber optic cables across oceans, building the first massive data centers? That was the project that literally wired our modern world. And the argument here is that we are living through that exact same kind of historical moment all over again right now.
And sitting right at the heart of this new digital backbone is one company, Nvidia. It's a name that's everywhere now, but it's kind of easy to forget that this AI giant got its start making graphics cards so we could all play better video games. So how on earth did a gaming company get here powering a revolution? Well, first, you just have to understand their position today. When you look at the specialized chips that are the engines for AI, these AI accelerators, Nvidia has what is basically a monopoly. We're talking somewhere around a 90% market share. I mean, that's not just being a market leader. That is a level of dominance you almost never see in the tech world. Their journey to this point was, frankly, a stroke of genius. Back in 1999, yeah, they were a gaming company. But the game-changing move came in 2006 when they launched something called CUDA. Now, CUDA was a software platform that let developers use the crazy parallel processing power of their GPUs for anything, not just for making games look pretty. So, when the deep learning explosion kicked off after 2015, guess what? Nvidia was sitting there with the one tool that absolutely everybody needed. Okay, so that brings us to the real heart of the Morgan Stanley thesis. Because this isn't about what Nvidia has already accomplished. They argue that Nvidia's growth is going to come in two separate, absolutely massive waves. And the first wave, the one that got us to this point, is actually the smaller of the two. And this slide breaks it down perfectly. Wave 1, which is happening right now, is all about migration. It's companies taking stuff they were already doing on old-school CPUs, data analysis, scientific computing, and just moving it over to NVIDIA's GPUs to get a massive, 100x speed up. And that's been wildly profitable. But Wave 2 is about creation. It's about building entirely new things with AI that you couldn't even dream of doing before. And here's the kicker about that first wave. Even if not a single new AI breakthrough happened, if innovation just stopped today, Morgan Stanley thinks this simple migration from old chips to new chips has enough steam to keep driving huge demand for NVIDIA's hardware for years, all the way through 2027 at least. It's like a built-in foundational layer of growth, no matter what. So if Wave 1 is the foundation, where does the truly explosive, world-changing growth come from? Well, this is where we get into Wave 2, and honestly, some of these applications are straight out of science fiction. Let's take a look. First, think about healthcare. We're not just talking about helping doctors. We're talking about AI systems that can read X-rays and MRIs all on their own, maybe even better than a human can. Or in the lab, using AI to simulate how molecules interact, which could slash the time it takes to discover new life-saving drugs. The amount of computing power needed for that alone is just immense. Then you've got the entire industrial world. Imagine AI running quality control on an assembly line, spotting tiny defects the human eye would miss, or predicting when a critical piece of machinery is about to break down days before it happens. We're talking about building fully autonomous, lights-out factories and logistics networks that run themselves. But the biggest opportunity of all in the long run might be robotics. This is what Morgan Stanley calls bringing AI into the physical world. It's about taking this intelligence off of our screens and servers and putting it into machines that can actually move around and interact with things in our factories, our warehouses, our homes. And that is where the need for computing power just explodes. Why? Because teaching a robot to deal with our messy, unpredictable physical world is infinitely harder than just crunching data. And this isn't just some far-off theory. NVIDIA is already all over this. They've built a foundational AI model called GROOT. And yeah, it's spelled like the character. It's basically a starter brain designed specifically for humanoid robots, giving them the reasoning and skills they need to learn and operate in a world built for humans. Okay, so this paints a pretty incredible picture of dominance, but a market this huge is going to attract some serious competition, right? So you have to ask the critical question. With this much money on the line, is NVIDIA's position actually safe? Can anyone really challenge them? Yeah, this is the multi-trillion-dollar question, isn't it? If the prize is this big, why haven't we seen Google or AMD or a hot new startup come along and make a real dent? Well, the answer is a lot more complicated than just building a faster piece of silicon. See, the whole battle really boils down to this: flexibility versus specialization. Most of NVIDIA's competitors are building something called an ASIC. Think of it like a specialized tool that's incredibly fast and efficient at doing the one single thing it was designed for. But NVIDIA's GPUs are different. They're more like a programmable Swiss Army knife. And in a field like AI, where the cutting edge is literally changing every few months, that flexibility to adapt to whatever comes next is a killer advantage. So NVIDIA's competitive moat isn't just a wall. It's more like a fortress with 3 layers of defense. First, you've got that platform flexibility we just talked about. Second, they have an insane speed advantage because they can support a brand new AI model with a simple software update, not a whole new chip design. But the most important piece, the deep foundational moat that locks everybody in, is the CUDA software ecosystem. We're talking nearly 2 decades of development that has made it the default operating system for the entire AI industry. And at the end of the day, that is the most important takeaway from the entire Morgan Stanley analysis. NVIDIA's real advantage isn't just about selling chips, it's about the software. They aren't just selling the picks and shovels in a gold rush. They've built the roads, the banks, the government, the entire operating system for the gold rush. They provide the whole platform. Which leaves us with one last, kind of mind-bending thought to wrap up. If NVIDIA's platform is already the operating system for AI in the digital world, what happens as that AI moves out of the cloud and into our physical world through robotics? Are we watching a single company build the platform that could become, in a very real sense, the operating system for reality itself? It's a huge question, and it really underlines the true historic scale of what's happening right now.